Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this group, we're going to be going over problems 1 to 5 of the Florida Algebra 1 end of course exams. If you have any questions about the contents in this presentation, just place your questions in the comment section below, and we'll be glad to provide you with support. Okay, so this is the computer-based practice test. We're going to be switching back and forth between the computer-based program on the browser and our text editing software. Okay, so question number 1 reads, Jeremy determines that the square root of 9 is equal to 9 to the 1/2. Part of his work is shown. Square root of 3 equals 3, which is equal to the 3 to the first power. And then 1 is 1/2 plus 1/2. And then this equals blank, and that equals 9 to the 1/2. Question, which expression or equation should be replaced in the blank to correctly complete Jeremy's work? Okay, so for this problem, you want to recall your rules of exponents. Okay, so let's talk about the specific one that I'm referring to. So something you want to recall concerning the rules of exponents is as follows. If you have a to the x times a to the y, if you have the product of two exponents with the same base, this can be written as a to the x plus y. So basically the sum of the powers. Okay, this follows that if you have an exponent with a power expressed as a sum, you can break this up. This is a condensed form. You can break it up into a to the x times a to the y. It's this rule here just written in reverse order. Okay, so this is the rule that we're going to be implementing in answering question number 1. So right now, this is where Jeremy is at. Jeremy is at 3 to the 1/2 plus 1/2. Okay, now the question is, can this be expressed as a product? Can it be expressed as a product? And the answer is yes. So since you have the sum of the powers, you can write it as the base raised to the first power of the addends times the base raised to the second power here. Okay, so you see x plus y, you can write it as a to the first number times a to the second number that has been added in the power. So we are applying the same principle here. So still, this is my x and this is my y, and then now it's being written as a product. Okay, all right, so this is the first part. Now the second property that you will have to recall in order to finish this problem off is as follows. Let's say we have the product of two exponents with the same power. So let's say you have a to the x times b to the x. Okay, guess what? These powers, since they're common or identical, can be factored out, and this can be written as a times b raised to the x power. Okay, now if we apply the same idea here, we can express this product of powers as is as though you're factoring out these 1/2, and then you're left with 3 times the two bases with identical powers multiplied by each other raised to the 1/2. Okay, this is the reverse of the power of a product. Okay, if you have the power of a product, you can distribute the powers to the factors, but if you're going backwards, you can factor out the powers from the product as long as the powers are identical, as in the case here, xx and 1/2, 1/2. Okay, so these two lines are the lines that Jeremy would use to complete the missing part of his work. Okay, so let's go back to the computer-based test. Our answer for number 1 is C, so just basically click that, and then you click next to proceed to the next question. Problem number 2 treats the table below shows the values of for the function y equals f of x. Complete the table for the function y equals f of 1/5x. Okay, so in this type of problem, you just click into the columns, into the respective cells, and you input your numerical results. All right, so let's go ahead and carry out the calculations first, and then we'll come back to this program and fill in our answers into this empty spots here that are highlighted in blue. Okay, so in this problem, we're dealing with transformations, okay, transformations on a function. Now we have our old function and a new function. This is our old function right here. And then we have a new function right here. Okay, we're given the numerical representations of the input and output table for the old function, and we're asked to use this transformation to generate input and output values for the new function. I'll snap over twice. So this is our new function right here, old and new. All right, so something I would like you to recall before we start on this problem, something to recall is that if you're going from f of x, your old function, to f of 1 over c of x, this transformation right here represents a horizontal horizontal stretch, sorry. So you stretch horizontally, by a factor of by c, okay? So that's the visual alteration on the graphical representation of this function, but we're dealing with numerical values here. What does this look like numerically? How does this transformation impact the coordinates of f of x under this transformation? So let's say for this is the old and this is the new. So let's say we have coordinate representations. So the old coordinates, let's say it's AB. Under this transformation right here, f of 1 over c, it's going to become c times a comma b. Okay, so this will be our old coordinate value, and this will be our new coordinate value. Let's study this for a second. What's happening here? Under this transformation, the y coordinates remain unchanged. There's no dilation vertically. But if you look at the A gets attached, is scaled by a factor of c. So that's the result of that's what causes the horizontal stretch of dilation by a factor of c. So what this formula is telling me to do is, in order to carry out this transformation, just simply multiply all the x coordinates only by the c factor, and that will generate your x values. The y values remain unchanged. Okay, so in this problem, we're going from f of x to f of 1 over 5x. In this case, c is equal to 5. All right, that's the dilation factor. So we're going to be going from xy to 5x comma y. All this is saying is multiply all your x coordinate values with 5 and leave the y's alone. Okay, so you just put 7, -2, 3, -4, 5. And then the first one is 5 times, so we're going to go -4 times 5. That's, what is that? -20. And then -1 times 5, just multiply everything by 5. That gives you -5. 0 times 5, that gives you 0. 3 times 5, that gives you 15. And then 6 times 5, that gives you 30. Okay, so our input values for this transformed function are -20, -5, 0, 15, and 30. Okay, so let's go back to the computer program. Okay, when you're entering your answers in the computer based test, you just click and then enter your responses. Okay, so the first one was -20. The next one you multiply by 5, that was -5. The next one was 0. Next one was 15, and the other one was 30. Okay, all our y values just stay the same, 7, -2, 3, -4, and then 5. Okay, so this is basically how you populate the field when you're dealing with open-ended questions of this nature on the EOC test. All right, let's take a look at question number 3. It reads, Max collected data on the height of each of his 20 classmates. The box plot shown represents his data, so we have this box plot here. Click above the number line to complete the dot plots that could also represent these data. So we have some plots here, dot plots, but they're not complete. We were asked to complete them in such a way that it's an accurate representation of this box plot right here. Okay, so in order to complete this, we just have to approach it in a systematic fashion. First thing we want to do is we want to take a look at the extremes, okay? The maximum, the median, and the minimum, okay? So if you look on this, this is complete, okay? This is incomplete, so we want to complete this using this as a guide. So we see that this value right here, 59, is our maximum. So is our minimum. So our minimum is 59. And then our maximum is 76. Okay, so let's write that down. Minimum is 59 and max 76. So what does that mean? It means that we should have points there to capture the entire range of our box plot. We don't have any points for 59, so what do? Put a point here for our min and put a point here for our maximum. Okay, so what guides the number of points? Well, you know what? Let me change the color so I can keep track of the alterations I'm making. So what guides the number of points that we put here? Well, how many individuals did Max collect data on? He collected data on 20 classmates, okay? So we need a total of 20 points. So let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. We need 8 more points to plot. Okay, so I'm just going to put a tally on the side here to keep track. So we have 1, 2, 3, 4, 5, 6, 7, 8 more points to plot. Okay, I already graphed 2 there. Okay, so next thing we want to look at is the median. So we're going to be looking at the median next. Okay, so the median, from this plot we can see that our median is equal to 65. Median is 65. So what does that tell us? How does that help us in this problem? Well, the median splits our points into equal numbers, okay? So the points to the right and to the left of the median, the total number of points should be identical. All right, so that's gonna help us a lot in completing this problem. So this is our median here. We're gonna start to split up the points that we have. All right, so let's go ahead and start from the right side. So on the right side, we have 1, 2, 3, 4, 5, 6, 7, 8 points. Now the median has already taken away 2 points, okay? So how many points can we allot to the upper half and to the lower half? So all you simply do is you take the total number of points, which is 20, subtract the number of points for the median, which is 2, you have 18. Now you're going to divide that by 2, you get 9. What does that mean? You're going to need to have 9 points to the right, and you need to have 9 points to the left. All right, that's what the median does. It basically splits the data set into 2 equal halves. So to the right of the median, I need 9 more points. I have 1, 2, 3, 4, 5, 6, 7, 8. How many points are missing? 1 more point. Okay, so where do we graph that point? We have the upper quartile, quartile 3. Quartile 3 is 70. Okay, so this right here is Q3. Let's write it on the side here. Q3 is equal to 70. Now what this quartile does is that, focusing on this data set right here, the third quartile that we have, what it does is it splits the data set into two again. Okay, so I need to reduce this. So I'm gonna omit the extremes. So you have to omit the extremes here. So looking at this right here, the third quartile, ignoring the median and the maximum, in between these two values, the third quartile splits it into two. Okay, so what am I saying? Is that the number of points to the left of the third quartile and the number of points to the right of the third quartile have to be exactly the same. How many more points do we need to the right of the median? We already talked about it. We had 8 points, so we need one more. So if you put that 1 point anywhere here, or even here, that will work, okay? So let's just put the point right here. Does this work? The answer is yes, because in this box I just drew, you have 3 points to the left of the third quartile, to the right of the median, and then 3 points to the right of the third quartile, to the left of your maximum. Okay, so we're basically taking advantage of this quartiles and medians and max and min and also symmetry to determine where our points lie. Okay, so that goes the last point for the upper half of our data set. Now we're going to switch to the lower half, to the left side of our data set. Left side of the lower half. Okay, so what we're going to be doing, let's put a nice little box to guide us. In between the minimum and the median, we have the first quartile, Q1. Q1 is equal to 62. Okay, that's your first quartile. Q1 is equal to 62. Okay, let's put that on our box plot right here. This is Q1, quartile 1. Now, what Q1 does is the remaining points in between our mean and our median, Q1 is right in the center. Okay, it's dead in the center. How many more points do we have to the left of the median? We already talked about that. We have 9 points. Okay, so we have to put 9 points here. 2 points already plotted for us, so we have 7 more points to plot. But we have to graph the 7 points in such a way that they are evenly spread across the median. Okay, there's so many different configurations that you can use. There isn't just one exact answer. Let me show you one configuration that I'm going to use here. What I'm going to do is I'll just add 1 more point out of the 7. I'm going to add 1 more point to the first quartile. Let's make that blue. Okay, so I have 6 more points that I have to plot. So how do I graph the 6 points? I simply break it into halves, okay? So if I put 3 points to the left and 3 points to the right, 62 still remains the second quartile because I split the points evenly to the left and right. Okay, so you have to make sure that you have that symmetry in order for your graph to work perfectly. Okay, so I'm going to put 1 point here and another point here, and I could put another point here. 3 points to the left of the first quartile. Okay, so now how many points do I have? Remember, I have the total. I need to have a total of 9 points here. I had 3 before, and I needed 6 more. I put 3 down, so I'm left with 3. Now, where do I want to put the 3 in order for these 62 to be right in the center? I have to put the other 3 to the right of the first quartile, to the left of the median. So it doesn't matter how you configure your points. You can just put a point here, put a point here, and put a point there. Okay, so you have a total of 1, 2, 3, 4, 5, 6, 7, 8 points. You have 3 to the right, 3 to the left, and 2 at the center. Okay, so that will guarantee your first quartile in this lower half to be 62. Okay, so you have to make sure that you preserve that symmetry, just as we did here. We had 3 to the left and 3 to the right. In order for this to be the third quartile, we had 3 to the left here and 3 to the right here in order for this to be our first quartile. Okay, so this is one of the answers. There are a lot of possible combinations using that symmetry. For example, I could take this point and put it here, and take that point and put it right here. We will still have 3 points to the left and 3 points to the right of this quartile. As long as you ensure symmetry, you should be fine. Okay, so we're back to the computer program. We're to plot our points here in order to get our points. So we're going to start by graphing our max and min. Our max was what was our maximum? 76. So all you do is you go to the spot where you want to put the point and you just click. Bam, see that? And then the minimum was 59, right there. And then we left our median alone. And then we said our third quarter was 70. We have 3 points to the right of it, less than the max. We needed 3 points to the left of it, greater than the median. So we decided to just put a point here so that we have symmetry, and this would be our third quartile. 9 points to the right of the median. We needed another 9 to the left of the median. So we said, okay, we have 2 points. We have 7 to distribute in this area. We put 1 on the first quartile. So now we have 6 points. So we said we put 3 to the left and 3 to the right in any configuration in order to preserve the midpoint nature of this first quartile. So we said, you know what, we just put 3 points here, 1, 2, 3, and another 3 points here, 1, 2, 3. This is one possible answer. There are other combinations that will work. Okay. All right, let's take a look at question number 4. We have this paragraph here that we have to read. It reads, a bird drops a stick from the top of the Miami Tower. Oh, that's interesting. The height of the stick after x seconds is given by this function right here, f of x equals 625 minus 16x squared. Question. Select all the correct interpretations of the coordinates of the point at the maximum of the function f of x. Okay, so we have to select all that apply here. So one cool strategy to solve a problem involving projectile motion equations is to give yourself a visual representation of the graph of the situation. Okay, so if you look at this right here, this is a parabolic function that's facing downwards. Okay, so if I plotted this quadratic function right here, which is a parabola, it's going to look something like this, a parabola that opens down, so something like that. Okay, now there are 2 important points we want to keep in mind in this parabola, which is the vertex right there and the 0, or the y-intercept. Okay, the vertex, as we know, is hk. If this function is written in vertex form, and then we have the y-intercept right here, which is some later x value when y is equal to 0. Okay. Now, what are the significance of these points? The bird dropped the stick from a particular height. And what did the stick start to do as soon as, let's say this is the bird right here. As soon as the bird released the stick started to fall straight down. Okay. So the height started to do what? The height started to fall. Okay. This function measures the height of the stick from the ground. So since the height starts to decrease as it gets closer and closer to the ground, the point in time at this vertex right here, I'm going to call it T max. This is a time when the ball was at its maximum height. And then the y coordinates is the maximum height specifically. Okay, so T of the vertex is the time when the stick was in its maximum height, and the y coordinate, the k, is the actual height, maximum height. Okay? Now, this point right here represents the time when the stick hit the ground. Okay? And what's the height? How high are you from the ground when you're on the ground? You are 0 units from the ground when you're on the ground. Okay? All right, so let's take a look at these 5 options here. We're selecting all that apply. Anytime you see select all, you want to watch out for multiple correct answers. Okay, so we're looking for all the correct interpretations of the coordinates of the point at the maximum. So this is where we're focusing on. This is the maximum. Okay, this is our focus. So what's the significance of this? T max, F max, the time it takes this stick to hit the ground. That is T ground right here. From this time T max to T ground, the time it takes, that's the significance of the x coordinate of the y-intercept. That is not what we're asked for. Okay? Option 2, the time when the stick is at its highest point. At what point is the stick at its highest point? At the maximum right here, at the vertex. So this is a correct interpretation of the x-coordinate of the vertex. Third option, the height of the stick when it is dropped. At the moment when the stick was dropped, what was the height? The height was the maximum. So this represents the y-coordinate of the vertex. So check. So let's write down the significance. This is x vertex, and this is the y vertex. Okay? Think about this as x vertex is our T max, and then the y vertex is our f max. Okay, so these two are correct interpretations of the x and the y coordinates of the vertex. Option 4, the time when the stick is dropped from the top of the tower. So when or where was the stick at the time it was dropped? It was at the maximum. So this is another way of writing the x vertex. Is your T max also. Okay, so this one is also the x coordinate of the vertex, which is your time when the stick was at its maximum. Just a different way of saying it. Last option, the distance of the stick from the Miami Tower when it hits the ground. This statement here cannot be determined. Why is that? Why can it not be determined? Well, the function measures the height from the ground. It doesn't measure the distance of the stick from the tower. So this one cannot be answered, so it's not relevant to this function right here. Okay? So our answers are options B, C, and D. Okay, so let's go back to the computer program. All you just do is just check the ones that are correct. B, C, D. Those are the correct interpretations of the maximum, also known as the vertex, of this parabolic function involving the drop of the stick. Okay, let's take a look at number 5, the last in this installment. Let's read. Some of the steps in Raya's solution to the equation 2.5 times 6.25x plus 0.5 equals 11 are shown. Question, select the correct reason for line 4 in Raya's solution. So we're going to be clicking on one of these correct reasons for line 4 in Raya's solution. Okay, so one tip we'd like to share with you all concerning problems involving missing steps or errors in student work. So let's share that tip with you guys real quick. Tip is involving missing steps or error analysis. This is also involved. This tip can also be applied there. What you want to do is you want to solve the problem completely first. Okay, don't try and figure stuff out just by inspection. Just solve the problem. When you solve the problem, they have a flow as to what's going on in the different steps, and then you can accurately identify the step that results in the reason that you've been asked to find. Okay, so that's exactly what we're going to do. We're going to solve the entire problem first. Just ignore this table for a second, and then we'll focus our attention on the step that we want to find the reason for. Okay, so we have 2.5 times 6.25x plus 0.5. You're going to be allowed to use a scientific calculator for this problem, okay? So multiplying these decimals, don't get nervous about it. Just use your calculator to carry out those multiplication processes. So first step in our problem solving process is to get rid of the parentheses, okay? So I'm going to distribute 2.5 into the two terms in the parentheses, okay? I'm just trying to simplify the equation. So when I distribute 2.5 times 6.25, enter that in your calculator, you end up with 15.625x. And then 2.5 times 0.5 is 1.25 equals 11. Okay, so that's step number 2. Okay, now next we're going to get this term with the x by itself. So what we're going to do is we're going to subtract 1.25 from both sides. 1.25, subtract 1.25. Okay, well, let's keep track of our steps. Okay, so this is 1, this is 2. And then if we carry out that subtraction, we'll end up with 15.625x equals, if you subtract this 2, you would end up with 9.75. Okay, let me write that again. 9.75. Okay, so this is step 3. What did we do to both sides? We subtracted. So you see why it says subtraction property of equality there? So we're looking good. To finish this problem off, we need to get x isolated. How do we accomplish that? We divide both sides of our equation by 15.625. 15.625. All right, and then just enter this in your calculator to compute the right side here, the quotient. On the left side, the 16.25 is divided out, so you have x equals, and we enter this into your calculator, you have 0.624. Okay, now what takes us to step 4? What is the reasoning behind the fourth step? What did we do to the equation in line 3 to get to 4? We divided by 15.625. So the correct answer is the division property of equality. Okay, so what we do here is just hover over division property of equality, click on it, make sure it's highlighted, and that's the correct answer for question number 5. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial beneficial to you in your preparation for the upcoming Florida EOC for Algebra 1, do give us a thumbs up. Your positive feedback is very important to us. Do not forget to subscribe for updates to the remainder of the SUM review series. If you have any questions about any concepts on the Algebra 1 EOC, just place your question in the comment section below and we'll be more than glad to support you. More clips can be found on mathcodeserve.com on the test prep. Thanks again for watching and have a wonderful day.